I'm giving you 3D models and even the full commercial license completely for free, just to show you how you can actually make real money with your own 3D printer. Thousands of these wax melt burner concrete candles are sold every month in Germany. But what about on Amazon in the US or other countries? Not a single product listed. That means basically zero competition, while we're out here making up to 500% profit margin per product, whether you just print the mold, make the silicone form, or sell the finished item yourself. I'll calculate all the material costs live in a second, while you, my one and only best friend, hit that subscribe button. The models are ready to go, 5 different designs, each with its own logo, from a cute Valentine's heart to the perfect gift for your hot mom. Yeah, we've got it all. And to show you exactly how it works, I've built the entire casting mold in a 3D animation, so you can see the whole process step by step. Alright, said and done, I dropped the files into the slicer and started the 3D print. The main product is now finished, but of course the support structures still need to be removed. With the standard settings in the bamboo slicer, that actually works really well, especially with matte filament, I've noticed. Now onto the housing for our casting mold. Meanwhile, the base plate is already printing. And just like that, the housing is done too. Inside there's still some support that needs to come out. Look at this. Modern 3D printers make really nice support structures these days. When I started, that was still a total nightmare if you used standard settings. This piece here is only meant to save silicone. So let's calculate realistic costs. Our first calculation: with 3D printing you only pay once and you can make hundreds of casting molds from a single print. That massively reduces cost if you plan to do small scale production. I got my Bamboo Lab for about 50% off the normal price including a spool, so around 13 euros. Even though I often pay with Maker Wall points and resell the spools for about 7 euros, today we'll calculate everything realistically, no coupons. At 13 euros per kilo, I enter that price in the slicer. I've activated supports and brim. By the way, how much do you pay for your filament? And which brand do you prefer? I've now sliced all 3 print plates, and with my filament the total cost is 8.02 euros, plus electricity and printer wear. The mold has a small hole. That's intentional since we're doing this professionally. The quick assembly you've already seen in the animation, now we're doing it in real life. On Etsy there's currently only one product at this level that's functionally similar, but it's much smaller and quite expensive. And even though I've made similar things before, this time I noticed I printed the main product upside down. Sure, we could still fix the lines, but that would require way too much post-processing. If you have a resin printer, you can absolutely do this with that. There's far less sanding involved. But I'm showing it with an FDM printer, because most of you probably don't have a resin printer. So I printed the container again, this time without a logo and with some cheap filament that I'm trying to use up. Since I printed it with the bottom facing upward, there's a lot less sanding to do. I also placed the seam intentionally in the middle, on a flat area. It's much easier to sand there than if it were on an edge. The side walls don't have to be perfectly smooth. You can even use a higher layer height. Now it's sanding time. And for those who think that's too much work, it's really not. You only make this mold once. You invest maybe an hour of work, and after that you can produce hundreds of molds, and you can sell them for a really good profit on Etsy or Amazon, since there's hardly any competition. And if there is, it's usually the same thin-walled molds from China that everyone has. I've sanded everything nicely, by hand of course. Then I washed off the dust with water, dried it, and it's ready for the next very important step. Even after sanding, you'll still see the layer lines. If you don't have spray, check your neighbor's garage, maybe he has some filler lying around. Just apply the filler evenly across the surface. In my case, it needs about 2 to 3 hours to dry before we continue. There's still a thin line visible on top, that has to go too. Things take a bit longer in my workshop, it's under 10 degrees in here, and the heater in the background doesn't work. For sanding, I use soft foam pads with a bit of water. That works great with filler. Normal sandpaper works too. If you have very fine grit, like 500 or 1000, that's perfect for the final pass. Alright, all sanded. There was one visible spot on top. I removed that as well, along with the topmost layer. If you're using a smooth build plate, you'll barely have to sand at all. It looks like a lot of steps, but most of them take only a few minutes. What really takes time is waiting for things to dry. Everything feels nice and smooth now. So let's move on to the first casting mold. I'm using a 2-component silicone with a hardness of 20A. That's a great balance for casting molds. I attach my container to the base plate with double-sided tape, as sanded as possible. since any offset will affect the wall thickness later. Then I add the walls and tape over that small hole. Otherwise, silicone will leak through. On top goes the part that helps us save a lot of silicone. I fixed with thin strips of double-sided tape on the sides, but you can also use hot glue if you want. Now hot glue really comes into play. Apply it anywhere silicone might leak out. The material is quite runny at first, and if something does leak, just press a piece of tissue on it. That usually stops it right away. Next up, mixing the silicone. 2-part silicone has to be mixed 1:1, either with a scale or with measuring cups. I'm using measuring cups today, 250 milliliters per component, so 500 milliliters total, and seriously, mix it really well. If any area isn't fully blended, it will never cure. That's exactly what you see in those negative Amazon reviews with bubbles and holes. Then my vacuum chamber comes into play. I know most of you don't have one, that's fine, especially if you're using self-degassing silicone. I bought mine back in my hype YouTube Germany days around 6 or 7 years ago. The air bubbles are gone now and the silicone looks perfect. Pamela Anderson would be jealous. When you start pouring, stick to one corner and let the silicone flow in slowly. That way the air can escape from below. If you pour from multiple sides, the silicone traps air between streams, creating holes in your mold. If you're not interested in the final concrete candle with the permanent wick, that's totally fine. Even the silicone mold itself, made from the 3D print, is a great product to sell. The 3D print keeps everything from warping when you cast with concrete or plaster. It holds everything nicely in shape. I've attached my piece with 2 small silicone strips and placed some weight on top to keep it from floating up. My silicone wasn't quite enough, so I quickly mixed another batch. Now I know the exact amount you'll need. 1050 milliliters of silicone. At my purchase price of 90 euros for 4.52 kilograms, that's about 23 euros. It's the same principle as with filament. From one PLA mold, you can make hundreds of silicone molds. From one silicone mold, you can make hundreds of concrete, plaster or resin containers. The more you produce, the lower your material cost per piece. If you only make one concrete candle in the end, we'll soon calculate how much that costs and what you'll pay for 5, 10 or more pieces and how much you can profit from them. Done. While my silicone is curing, take a look at the average price for molds like these. Keep in mind those are prices in euros. We'll convert them to dollars next. And these aren't just listings, they're products that actually sell. The 3D print files are also included in the package, but I'm skipping that part today since I'll be laser cutting the wooden lid instead. The silicone rubber should be cured by now. Don't worry, it overflowed a bit because I moved it into another room that's warmer than here, so it could cure faster. I just shook it a bit too much. I'll remove the hot glue later with a utility knife. For the bottom plate, I need to press it a bit since I attached it with double-sided tape. Now I'll remove the casing. The casing from the 3D print can actually be reused for more silicone molds later on. Now here's a pro tip. Many people recommend coating the 3D print with some kind of release agent, but I use a regular air pump for footballs, and that's exactly why I modeled a small hole into the piece so the needle can go in, and with air pressure it pops right out, kind of like a pneumatic release. The top part broke off, but that's not a problem. I'll cut away the extra silicone on top and then take out the printed container. The silicone walls are thicker than the standard casting molds you can buy, because this is a high quality product made for many uses. Thick walls mean long lifespan. Let's check it out. On top we can see some 3D ridges. Totally unimportant. Maybe wax will even stick better because of that. The inner surface will be smooth. You'll see it once the wax has melted, but the most important thing is this outer wall, because that's going to be the outside of our concrete container, or plaster or epoxy resin, whatever you want to make it from. It's just perfect on all sides. Now my concrete mix, I'll keep it short. I use about 1 part cement to 2 parts sand. I also add a small secret ingredient, but that's not necessary for making concrete. Just a tiny bit of black iron oxide powder to make it a little darker, since I'm using white cement. By the way, white cement is great if you plan to color your products later. If you just want gray, use regular cement. I also use a plasticizer, very little of it, about 4 milliliters per kilogram of cement measured with a syringe. Always calculate all ingredients based on the amount of cement. If you're doing this yourself, mix about 1,300 grams of concrete. In my case, 1,300 grams of concrete with my current prices, and I usually buy expensive stuff, often on Amazon. with white cement, quartz sand, 0.2 to 0.7 millimeters, plasticizer, secret ingredient, black iron oxide and fiberglass, comes out to just over €1 per kilogram. For this container at 1,300 grams, my total cost so far is about €1.50. If you want to make concrete lids, mix about 350 grams more concrete. I'll show you the full mixing ratio here, but you can adjust it a lot, especially if you're using different cement or plasticizer. I built my own concrete vibrator because the big ones are super expensive and the small ones, like the ones used by dentists, are just too weak. It's a gadget you don't need in the beginning, only later when you really get into this. Before that, just tap the mold against the table by hand until all air bubbles are gone. If too much water stays on top because of the plasticizer, just soak it up with a napkin. We're doing this professionally here and cheaply. While the concrete reacts chemically and hardens, I laser cut my lid. And yeah, most people won't have a laser, that's why I've included a 3D printable file for the lid mold for you to download. I'm doing it with the laser. 2 plates, and that's how the lid looks in the end. It's actually designed to extinguish the candle. Just place it over the container, and since no oxygen can reach the flame, the wick goes out. There are already over 100 camera cuts in this video. If I don't get a like for all this work, that would be sad, especially since my channel isn't monetized. Let's keep going, friends. The concrete is hard enough to be removed now. The 3D printed mold comes off and I pull the container out partway, but not completely. Inside is the 3D printed insert I mentioned at the beginning. Again, I'm using the air pump and that small hole. Look how well it works. The walls look okay. I've made cleaner pieces before, and a few small holes in the concrete are totally normal. It's part of the look and sometimes actually enhances it. There just shouldn't be too many. Here, I could have tapped the silicone walls a bit more before pressing the 3D print around the mold lid test. It fits perfectly, so the dimensions stay as they are. Here I have some smaller similar containers. I've already optimized the mixture for those. They look fantastic. I felt pad on the bottom as scratch protection and a wooden snuffer lid. I'll add the felt protection here as well. By the way, most competitors skip this step, but honestly, it costs around 10 cents per candle. I'll cut it with a laser. If you don't have one, just use scissors. You can print the template from the SVG file. And if you do have a laser, use the same file as for the lid earlier. Just cut the smaller square, which matches the exact dimensions of the concrete base. One thing's still missing: wax. And honestly, it's a lot of work to get to this point. It already started with the 3D modeling, and everything up to here took quite some time. But with this silicone mold, you can pour about 1 container per day. With plaster, probably 10 per day, but those won't be suitable for outdoor use. Once sealed inside with wax, and I use a permanent wick. Why is it called a permanent wick? Because if you add leftover wax into the container after burning, it absorbs fresh wax again and keeps the burning for many days or even weeks. The height is important so the lid still closes. In my case, I need to trim it a bit. For indoor use, you can also make these containers from plaster or similar materials, with wooden wicks or multiple string wicks, since this is a large container. The lid fits now. The felt goes on the bottom and I heat the container thoroughly with hot air. Technically, you should wait another day so the concrete is completely dry. But this container is just for the video, and I want to finish it now. Container preheated, and now I pour in the warm, liquid soy wax. It helps if the room temperature is above 22 degrees, so the wax doesn't cool too quickly. Pre-warm your containers well, especially glass, to avoid frosting. The soy wax I use is very high quality and actually meant for other types of candles. For outdoor candles, inexpensive paraffin is more than enough. The wax sets a bit too fast here, so I add a bit more. In goes the good stuff. I really like it, just like the subscription you're about to leave, and that's it. Thanks to the heat, the concrete container has dried as well. As I mentioned, the concrete needs to be fully cured. Before adding wax, I think the piece looks really cool. You can also offer these products scented with essential oils and achieve high profits with very low costs. The first concrete candle will barely cover your expenses since the steps from 3D printing to silicone mold are a bit pricey. But once the silicone mold is made, each candle costs under €8 in materials. And remember, I'm using expensive cement and very high quality soy wax. Depending on your country, you can probably bring the cost down to under €5 per candle. And at this size, they sell for around €50, and thousands are purchased every month.